Hello students, welcome to all. This is Dr. Vigneshwar Mekha, lecturer in geography, Government Degree College for Women's, Begumpet. Today we are going to discuss about the interior of the earth. As a part of this interior of the earth, uh, we are going to discuss about few points regarding the interior of the earth as a part one video of the session. Points to be covered in the Earth's interior are: 1. Introduction to Earth's interior. 2. Problems of interior knowledge of the Earth. 3. Sources of the Earth's interior. That is, in that sources, we are going to discuss about artificial evidences and natural evidences. Thereafter, we are going to discuss about composition and structure of the interior of the Earth. In this, we are going to discuss about crust, mantle and core, and mechanical divisions of Earth, and discontinuities of the Earth's interior. And let us start the module 3, the interior of the Earth. The Earth on which we live to be full of mysteries about its appearance, motions, land, air, and water, external morphology such as mountains, valleys, plateaus, plains, lakes, and ocean can be easily studied. But the interior structure and composition are simple to understand. Even with present tools and techniques of motor age, man has been constantly trying to know what about the earth right from present historic days. Gradually, he has succeeded to get some details of the interior of earth. The information of the composition and internal structure of the earth has been always remained a matter of great controversy among the geologists and geophysicists. Today, there is a lot of knowledge available about the Earth's interior. The study of the Earth's interior is, however, important for geographers because living on the Earth's solid surface, we are very aware of the materials that surround us and the process that alter them. Deep earth mining and drilling reveal the nature of rocks deep down the surface. But as mining and drilling are not practically possible beyond a certain depth, they don't reveal much information about the Earth's interior. Poning Gold Mine, the deepest mine in the world, and Chautana Gold Mine, the second deepest mine in the world, in South Africa, are deepest mines reaching to a depth of only 3.9 kilometers, that is around 4 kilometers, and the deepest drilling is only about 12 kilometers deep hole bored by the Soviet Union in the 1970s over the Kola Peninsula towards the exploration of the petroleum deposits. Now, we will look into the problems of interior knowledge of the radius of the Earth is about 6,371 kilometers. This depth is difficult to penetrate up to the center of the Earth. The next is the present technology when is unable to give us direct references about the interior of the Earth. And the interior temperature starts to increasing with the rate of increasing of temperature is 1 degree Celsius for every 30 or 32 meters. The relative density of the Earth's interior increases with increasing depth. It is about 5 times higher than the outer crust, that is continental crust. holes have been drilled to a maximum depth of about 10 plus kilometers into the earth, National Academy of Science of United States made effort to drill the Pacific Ocean bed near the California for direct information about this project known as MOHO project. The name of the scientist was called because of the great expanse. Similarly, over the Kola Peninsula, the United Soviet Union has also dug about 12 kilometers for sake of the exploration of the petroleum deposits. Besides, pressure also increases from crust to interior, from crust to the interior parts. Because as the depth increases, the pressure increases. Now let us focus on the sources for the study of the earth indeed. There are two main sources which helps geologists and geographers to know about the interior of the earth, the composition and interior of the earth. They are: one, evidences based on artificial sources, and two, evidences based on natural sources. Now let us discuss about each of these sources in detail. The artificial sources includes specific gravity in their density, and let us discuss about each of these artificial sources in detail now. Internal compartment of the earth is not uniform. Most of outer parts of the earth, known as crust, has been made up of mostly of the sedimentary rocks. Crust making rock of the earth processes is specific gravity around 2.8 grams per cubic centimeters. The average density of the whole earth is about 5.5 grams per cubic centimeters. Thus, it appears that the density of the core of the earth will be without no doubt more than 5.5 grams and 5.5 grams cubic centimeters. In general, the density of the core of the earth is around 11 grams per cubic centimeter and more. Australian scientist K.E. Bullen studied this issue intensely and concretely and gave inference that deep interior of the earth is a massive, heavy mass of metallic nature under tremendous pressure. Earth being a magnetic sphere, core of might be made of nickel and iron. The second is the pressure. Pressure in itself is not responsible for the increase in density. Rather, the core is composed of intrinsically heavy metallic materials of high density. Similar to the temperature, the pressure of the earth also increases. The pressure at the surface would be 0.1 millions per atmospheric units. If one goes to the 10 kilometers, it would be 300 million parts per atmospheric units. And as we move towards the depth increases more and more at 100 kilometers, 3200 million parts are atmospheric units, and at the center 3,64,000 million parts atmospheric units. Then the temperature is another artificial source to study the Earth's interior. There is a rise of 1 degree Celsius with every 32 meters of depth inside the interior, Earth's interior. And this rate of increase is uniform everywhere, and it is not uniform in everywhere inside the Earth. The temperature at the depth of 50 kilometers, it should be around 1500 degrees Celsius. It is therefore clear that the solid layer of the Earth is a thin film over the otherwise molten metal. Evidence based upon the temperature indicate that middle layers exist between 1200 to 2900 kilometers of the depth. The lowest layer is considered to be about 2900 to 6400 kilometers, around or 6378 kilometers depth from the surface. The temperature of Earth's interior would be 1200 degrees Celsius at 100 kilometers depth, 100 kilometers at 150 kilometers depth, and around 5000 to 6000 degrees Celsius at the core of the Earth. In reality, it would be about 20,000 degrees Celsius according to the rate of 1 degree Celsius per 32 minutes, but based on the sources from the scientists, the rate is about not uniform, and the actual temperature at the center would be about 6000 degrees Celsius. And another artificial source to study about the interior of the Earth is meteorites. Meteorites and Earth are born from the same nebular cloud. Therefore, they are likely to have a similar internal structure. When meteorites they fall to the Earth, their outer layer is burned during their fall due to the extreme friction, and the inner core is exposed after the burn. The heavy material composition of their cores confirms the similar composition of the inner part of the Earth. Meteorites hitting the Earth allow us to determine the density, mineralogy, chemistry of the nickel, iron core of the bodies having a similar composition to that of the Earth's interior. Next, we go to the natural sources. The natural sources are the very important, which help us with the study of Earth's interior, the knowledge of Earth's interior. The natural sources include volcanicity and evidences from the seismology. First, let us look into the volcanicity. Several geologists, on the basis of upwelling and spreading of hot and liquid lava, that is molten rock material, on the Earth's surface during the volcanic eruptions, believe that there is at least a layer below the Earth's surface which is in liquid state, based on the evidences from the eruption of the molten rock material or the lava. And another evidence is that evidence is from the seismology. It has been experimentally proved that three types of waves are produced at the time of the earthquake from the focus of the earth. And these waves include primary waves, secondary waves, and surface waves. And these waves are also known as the seismic waves. Seismic waves travel times and directions give indication of internal structure of the earth. P waves. Primary waves push and pull moments travel fastest, travel through solids and liquids. Secondary waves move side to side, slower, travel through the solids only but not in liquids. P waves or primary waves are the fastest of all the seismic waves, travel horizontally and can penetrate the change of medium to some extent. These waves cannot penetrate the liquid medium. P waves travel 1.7 times faster than S waves. P waves lose their speed near outer core, which is therefore supposed to be a liquid then again after 1250 kilometers. From outer core, the speed of the P waves increases. The S waves or the secondary waves or transfer waves. S waves are also useful to understanding interior of the earth as S waves travel at right angle. These waves are cannot pass through the liquid medium. Therefore, part of the core is liquid. These observations clearly shows that up to kilometers the interior is solid with the increasing density. Then the central mass must be in a liquid state. Surface waves, also known as EL waves, longitudinal waves. Surface waves also throw light on density differences of the outer crust of the earth. These surface waves travel faster on ocean bed than when they travel on land surface or continents. The surface waves affect only the surface of the earth and covers the longest distance of all seismic waves. It has lower speed than the P and S waves, but is of most violent and destructive nature. These waves get reflected and refracted while passing through a body having heterogeneous composition and varying density zones at the distinct points. While the S waves or SO particles move at right angles to the rays, these waves cannot pass through the liquid medium. So P wave velocity depends upon the elasticity, rigidity, and density of the material. By contrast, S waves velocity depends upon only the rigidity and the intensity of the material. In most rock types, P waves travel between 1.7 and 1.8 times more quickly than the S waves. Therefore, the P waves always arrive first at seismographic stations. P waves travel by a series of compressions and expansions of the material through which they travel. The S waves, slower waves, also called as shear waves, move like a wave in a rope. This movement makes the S waves more destructive to the structures like buildings and highway overpasses during the earthquakes. Because S waves cannot travel only through solids and cannot travel through Earth's outer core, seismologists conclude that the Earth's outer core must be liquid or at least must have the properties of a fluid. And this also proves that there are various layers of different densities and medium which split the waves in many parts. It is meant the Earth is made up of various shells based on the movement of the P, S, and L waves over the surface and indeed of the Earth. And here the S waves are making the shadow zone between 103 and 103 to 103, both sides of the earthquake focus, and whereas the um, P waves are creating earthquake shadow zone between 103 and 142 degree angle over the earth surface. Based on these sources, we come to a conclusion that the earth, in some parts of the earth are in liquid, and while in some part are solid in nature. Dear students, so far we have discussed about the following points in these sessions: introduction to Earth's interior, problems of interior knowledge of the Earth, sources of the Earth's interior. In this we have discussed artificial evidences and natural evidences. In the next session, that is in the interior of the Earth part 2 video, we will be discussing about the structure and composition of the Earth's interior, mechanical divisions of Earth's interior, and also the discontinuities of the interior of the Earth. Till then, stay home, stay safe. Thank you and thank you very much.